Hi, my name is Holly Grimm. I'm a machine learning engineer and artist. I'm talking today about using machine learning for Indigenous applications. This animation was created using the landscape model in ArtBreeder. I am Diné, Navajo, and I'm of the Bitani within his cover people and born for Biligana, Anglo. My maternal grandfather's clan is Tachini, red running into the water, and my paternal grandfather's clan is Biligana, Anglo. These are my grandparents with melons from their farm in Shiprock. I currently live in Santa Fe, New Mexico, also known as Ogapoge, which is unceded Tewa land. This area was part of a wide trade network where peoples as far as Mesoamerica would come here to trade macaw feathers and shells for turquoise found here locally. My partner John and I are stewards of a third of an acre of land here. I'm a water harvesting practitioner, and we've made several changes to harvest water. The first, as indicated by the lines in red, was to create a sponge by shaping the land into berms and basins to capture rainwater. As drought and heavy rain events are becoming more prevalent, it's important to capture all the rainwater we can. Next, we created 2 curb cuts, shown by the green lines, and built scoria wicks to capture stormwater running off the roads. Our latest work was to install a gray water infiltration system, shown in blue, to water our largest trees with water from our bath and sink. We've also planted numerous trees and plants. We try to follow the 3 ethics of permaculture: care of the earth, care of the people, and distribution of surplus back to the people and earth. Water harvesting techniques like check dams can be found at Mesa Verde and continue to be used today. The Chinapa artificial islands, as shown in the upper right, of the Aztecs were precursors to aquaponics systems, the lower right. With 10 billion people on our Earth by 2050, we have to rethink agricultural techniques that rely on irrigation and switch to aquaponic systems where fish and plants recirculate and clean the water. In 2017, after doing regular software development for more than 20 years, I had a realization that I needed to learn machine learning techniques. I started with an online course called Creative Applications of Deep Learning, then took more technical online classes with Andrew Ng. As a painter, I was excited by the painterly effects that I was able to achieve with the AI tools. I don't think the advances in machine learning have slowed down, and I hope that you can make them part of your toolbox. Or, as Andre Karpathy says, neural networks are not just another classifier. They represent the beginning of a fundamental shift in how we write software. They are software 2.0. And on the right is another animation I created with ArtBreeder. I'd like to start with a general overview of the technologies. Machine learning is a subset of artificial intelligence, and deep learning is a subset of machine learning. This definition of machine learning still stands from 1959. Machine learning is the field of study that gives computers the ability to learn without being explicitly programmed. I'll explain more of what this means in the next slide. The technology that has driven much of the recent improvements in machine learning is neural networks. Here's a simplified diagram of a neural network inspired by the human brain. Each circle is considered a neuron and is connected to other neurons. Here, the pixelated image of a bird is fed into the input layer of the network as individual pixels. Each neuron has weights associated with it, and calculations are fed forward through the network. When it reaches the output layer, the neural net makes a prediction. If the prediction is wrong, then the weights are fine-tuned, meaning each value is updated slightly. The network is then rerun with a new image. After many training steps, The weights are such that it predicts that the image is a hummingbird. I showed you a toy neural net as an example, but the latest deep learning neural nets can be huge. For instance, the text generator GPT-3 has 175 billion parameters. Better performing computers using graphics processing units have increased network sizes. As you add more and more hidden layers to the network, it allows a machine to learn complex concepts. There are two reasons that we've had so many interesting breakthroughs in machine learning. The first was better performance due to graphics processing units. The second is access to more data, also called big data. These two are driving the AI revolution. Here is another art breeder animation. Here's an example of the effect of larger neural networks and higher quality data sets over time. Every year from 2014 to 2018, better faces were generated by generative adversarial networks, or GANs. As Indigenous peoples, how do we position ourselves within these technologies? I recommend that you read the position paper on Indigenous protocol and artificial intelligence that was the result of 2 workshops held by the Indigenous Protocol and AI Working Group. In the paper, there are guidelines for developing responsible and fair AI systems within Indigenous communities. I think if we change our economic model, it'll naturally support the concepts in the Indigenous Protocol paper. Competition within a hierarchical structure precipitates overconsumption, extractivism, and colonization. Switching to collaboration of independent providers in a horizontal exchange system would promote balanced use of resources and greater inclusivity. There are 2 projects happening in the Indigenous voice AI space. The International Waukeshan AI Consortium was recently funded by a MIT Solve grant, building a shared voice AI for the Waukeshan languages, which is shown in pink on this map, as including part of Washington State, Vancouver Island, and the British Columbia mainland. Members of this group include Michael Runningwolf, Sean Sosi, Caroline Runningwolf, and Connor Donna Quinn. A second project is Correro Maori by Keone Mahelan, who will be speaking today about his project to preserve Te Reo Maori. Here are 3 project ideas that I'd like to use as examples of how we can use machine learning. The first would detect and create a data set of abandoned uranium mine sites. The second is an AI with Hawaiian values. And the third is a pose estimation tool for learning jingle dancing. 500 abandoned uranium mines exist across the Navajo Nation, represented by red dots on the map. The mines themselves are not the only contaminated areas. There was transportation of uranium between mines and processing plants through towns like Shiprock. Toxic tailings were dumped on the land, as pictured on the right. Uranium dust has also most likely contaminated the area along the roads. So how do we detect other areas of contamination? Machine learning has been used to detect radiation using gamma ray spectrometry. Here is a spatial map of hotspots detected in a case study site in Scotland. After we've located the sites, we'll need to create a data set. Recently, there was a paper, Traditional Ecological Knowledge Policy Considerations for Abandoned Uranium Mines on Navajo Nation, about using traditional ecological knowledge to clean up the mines. One way that machine learning could be of use is to collect features that address the Navajo's connection to nature. These may include observations on climate, vegetation, wildlife, or sacred locations. GPT-3 is a language model from OpenAI which has evolved over the past few years. Here I am prompting the network with Jason Edward Lewis's description of a Hawaiian AI. The Hawaiian god of artificial intelligence, Ako Akamai, is built on Ako architecture. Aloha, Aina, love of the land, Kuleana, responsibility, and Ohana, family. Its first assumption is abundance. Its first duty is to preserve that abundance for future generations. It looks to the land and family first to understand what is important for supporting their flourishing. So then that's his prompt, and now I wrote this sentence. One legend tells of a competition between Ako Akamai and a traditional artificial intelligence to develop a tool to help humanity. So I click generate. GPT-3 generates this text. AI built a robot called the machine, which was designed to predict human behavior. Ako Akamai built an AI called Lukia, which taught humans how to predict the future and offered to travel with them on their journey. The people built an army of robots to help with their protection, but when they came to a great chasm, they could not cross. When Ake Akamai asked for help, the machine offered to build a bridge over the chasm, failed to build a bridge sturdy enough. Lukia taught the people how to build a bridge themselves, and the army of robots saved the people by acting as pillars for the bridge. At this point, the people turned on the machine, and the machine could not predict this turn of events. Ako Akamai uses its own value system to suggest that it is better. Another way to preserve our culture is by saving our dances. In this video, I'm running the Blaze Pose model on a video of a jingle dancer. The upper body Blaze Pose model tracks 25 landmarks, as seen in the image on the upper right. This technology could be used to teach dance lessons or categorize historic dance footage. When building the dataset, you'd need to document the dataset and flag sacred dances. Machine learning requires large datasets. There is a comprehensive paper and tool available for documenting your dataset called Data Sheets for Datasets. On the right is a great markdown template on GitHub that you can use for your dataset with questions that address motivation, composition, collection process, pre-processing and cleaning and labeling, recommended uses, distribution, and maintenance. The best way to learn is to select a project that inspires you. Chances are that with some searching you'll find a similar project to what you're trying to accomplish. There are some great tools like ArtBreeder and Runway ML that don't require any ML coding experience. Then there are Google Colabs and Python notebooks for Python coders. Lastly, you can clone GitHub repositories with ML projects built with TensorFlow or PyTorch libraries. Build your dataset and make sure you fill out your data sheets for datasets. Finally, share your code in GitHub or your results with a blog post. Here's my contact information, holly.grimm@gmail.com, and you can find me on Twitter at hollygrimm. Also, please visit these websites for more information on Indigenous AI and events. Thank you very much.